I'm going to present you the preliminary geochemical results. So let's go to Arufu. I will be sending you all these files. So this is the area of Arufu. First, I'm going to connect the samples. This is a combination of the soil sampling and the rock samples for this area. As part of the composition of that analysis, we determine the presence of atypical samples. These are samples that are really different from the rest, not by just one element, but by the totality of the elements. So you can see there is a lot of atypical samples here. I did a very rough element analysis, just following the main creeks here, but that will allow us to do a better interpretation. I'm gonna deselect this thing. We have many ways of presenting the data. I did several type of maps after processing the sample using compositional data analysis, RapidMiner, Weka, etc. Of course, I can present you all the results, but I'm just going to jump to the last summary maps. What I call the multiplicative map are the areas that when you combine the best anomalies for the lead zinc mineralization, you get these areas here. A much better way of processing and presenting the data is what I call the total quartile, where I just, for each of the parameters I have studied, I converted them to quartiles, and the higher the quartiles, the best the results. Actually is in a percentage. So when you click on that one, you see that most of the lead zinc mineralization is on this area here, little bit there, and corresponds also to the multiplicative. It may be interesting to look at this part. Of course, you can see there, you have the open pit, you have the total quartile there. But there is a method in geochemistry that allows you to determine the erosional level of your deposit, meaning the part that has been already eroded. So you may have a beautiful high-level anomaly somewhere here, but it's just a residual anomaly because it has been eroded. The method is based on a coefficient between the supra-elements and the infra-elements. Example of supra-elements, we usually have mercury, zinc, barium. Example of infra-elements, we have nickel, cobalt, chrome. So when you do a coefficient of that, any value that is 0 or negative, that means that the anomaly has been eroded. So this is a very important step in interpreting geochemistry. So when you click this, you will see that regrettably, most of the area has been eroded. We still have some targets here, here, and here. Now, when you multiply the multiplicative plus the total quartile, that is the absolutely best target that you may have, you get 3 targets. Target 1 is right here. I'm gonna zoom in. This part here apparently is related to an open pit already, but this is the best one, and it has potential to expand to the east and to the northeast. So this is the best target that you have here. The second best target is right here, also associated to an open pit. But why this is second? Because it is partially eroded. It's very high intensity, but it's partially eroded. And the third one is here, but it's completely eroded. Again, the erosional level is not written in stone, but it's an indication. So by comparison, this target here is your best target. But as you can see, there is also this one here, and all this part here. It's evident that the mineralization is associated to the main faults here. So these faults must be controlling the mineralization. It would be very nice to see the geology here and also to compare these results with the geophysics. Thank you for the attention.